Hello students, welcome to the cbse chemistry lecture series. The last video we discussed about detection of elements. Various elements present in the organic compounds like carbon, hydrogen, oxygen, nitrogen, sulfur, halogens and sometimes phosphorus. So today we are going to discuss in this video is quantitative analysis. What is a quantitative analysis? So in the last video we discussed the detection of elements. The next step is to determine or how much amount of that elements are present in the organic compound. That is called quantitative analysis. Okay, first we will discuss the principles involved in this one. So first case, estimation of carbon hydrogen. Estimation of carbon and hydrogen present the organic compound. Normally we can call it as Lix method. Lix method. The name of the method is Lix method. First we will see the principle involved in this Lix method. A known mass of an organic compound is heated strongly with excess of dry copper oxide in a current of dry air or some oxygen which is free from carbon dioxide. So under these conditions, the carbon present in the organic compound is oxidized to carbon dioxide and the hydrogen present in the organic compound is converted to water vapor. So as shown in the figure, you see the figure, in the left hand side we are passing the pure dry oxygen. Inside that's a condenser like what? Apparatus is there. In that one we are having a Bunsen burner. Under the Bunsen burner is on burning. A platinum boat is there. In that platinum boat only you have to keep the organic compound, say for example W gram. And that in the adjacent side there is a furnace is there where we kept the cupric oxide, which is a black color compound. So on this reaction, there is a combustion tube, the reaction will take place and carbon dioxide and the water vapor will pass out from that combustion tube. In the next one we are having the U tube which is filled with calcium chloride. This calcium chloride, anhydrous calcium chloride is nothing but what? Whatever that water vapor coming out, that will be absorbed by that calcium chloride U tube. So before doing the experiment you have to weigh the U tube with the calcium chloride, anhydrous calcium chloride alone. Then after that what? Water vapor will be absorbed by this calcium chloride. Then you have to weigh that one. That we can take as a W1 or W2. We can have to fix as a mass of a water vapor. The another one, U tube containing potassium hydroxide. In that potassium hydroxide, the carbon is oxidized to form a carbon dioxide. That carbon dioxide will be absorbed here. The potassium hydroxide will be converted to potassium carbonate. And before doing the experiment and after done the experiment, you have to weigh the tube and find out how much amount of carbon dioxide is absorbed here. So you have to weigh that one. That is what? Mass of a carbon dioxide, that is W1 gram. So this is a Lix apparatus. So from this apparatus we are finding our estimation of carbon hydrogen is here. Yes, now we can derive the formula for this estimation. Say for example, carbon which is present in the organic compound, which is treated with a cupric oxide CuO, that will be converted to carbon dioxide just on heating is, and copper. You have balance the equations also, CO2 and Cu. Suppose if it is a hydrogen is present in the organic compound, when it is treated with what? CuO, what will happen? It will become converted to water vapor and copper will be there. Yes. Clear. Next we have to do the calculations. Suppose I already explained in that diagram, the calcium chloride is absorbed the water molecules. How much amount of water molecule is absorbed here? It will become a CaOH twice plus HCl. And Similarly, if it is a potassium hydroxide is there, that will be absorb the carbon dioxide gas. It will becomes K2CO3 and H2O. Okay. Now we will see the calculations. So let us define the mass of an organic compound. Mass of an organic compound, say W gram. Mass of carbon dioxide, that is W1 gram. Mass of water, that is W2 gram. We know that carbon dioxide molecular mass is 44. 44 gram of carbon dioxide containing 12 gram of carbon in that carbon dioxide. Suppose if it is a W1 gram of carbon dioxide will containing how much amount of this case? That means, so 12 divided by 44 into W1 gram. Suppose in the organic compound, W gram of organic compound, how much amount of carbon is there? So we can find out what percentage of carbon in this organic compound is 12 divided by 44 into W1 is nothing but mass of a carbon dioxide and W is the mass of an organic compound into 100. That is a method of finding the percentage. Or we can also say percentage of carbon is equal to 12 is the mass of what? Atomic mass of carbon atom. 44 is the molecular mass of carbon dioxide into mass of carbon dioxide divided by mass of organic compound into 100. So this is the formula for finding the percentage of carbon in the organic compound. Similarly, we can find out the percentage of hydrogen. How can you find out the percentage of hydrogen? We know that 1 mole of water vapor, that is 18 grams. 18 grams of water containing 2 gram of hydrogen. Suppose if it is a W2 gram of water will containing how much means 2 divided by 18 into W2. Suppose if it is the mass of hydrogen present in the W gram of organic compound. Mass of hydrogen in W gram of organic compound means we ought to say 2 divided by 18 into W2 by W. Suppose if you want to find out a percentage of hydrogen is nothing but 2 divided by 18 into W2 by W into 100. Same thing if we explain in terms of what is W1, what is W2 and what is W means percentage of hydrogen is equal to 2 divided by 18 into mass of water by mass of organic compound into 100. That is the formula for finding the percentage of hydrogen. Already in the last class I told you that if you want to find out a percentage of oxygen means 100 minus percentage of other elements present in the organic compound. Other elements present in the organic compound OC. That is a method of finding the percentage of oxygen. Thank you students. If you have any comments, please mention in the comment box. Once again we will thank you.